back to Algebra 2. Welcome back to Algebra 2. Before we look at some examples of the warm-ups, we need to remind ourselves of the rules of exponents. So when we see that we're multiplying the same base to two different powers, we add the exponents. When we are dividing the same base with two different powers, we subtract the exponents. When we take a power to a power, that's when we multiply. Anything to the 0 power is 1, and a negative exponent doesn't make the number negative, it makes it the reciprocal of the base. So if we have one base, it's going to go to the denominator. If we have the base already in the fraction, it will come to the numerator. So keeping those rules in mind, we need to be able to simplify these. So pause the tape and simplify. So since we have the same powers, since we have the same bases, we're going to do 3 to the n minus 2 equals 5, and then we can set the powers equal to each other. N minus 2 equals 5, so n is 7. Same type of thing happens here. We end up with solving 4 minus n equals negative 2. So when we simplify that, I'm going to move the n to the other side, and n is 6. Here we have multiplying powers, so we have 2n equals 5 halves. And then we divide, so we end up with, of course it's hiding a little bit, and we end up getting 5 over 4. Then, this is the trickiest, and the reason it's the trickiest because we have 2 to a power, so this side, the power is 8n. And we need to get this side to the same base, so we end up replacing the 4 with 2 to the 2 power. So 8n equals 2. Dividing that, I get n equals 1/4. This one becomes 2n minus 3 equals, don't forget about the 1's here. And once we solve that, n is 2. And 2n plus 1 equals negative 5. So 2n equals negative 6. N is, and I know it's off the screen, negative 3. So now we're going to switch from the rules of exponents to the rules of logarithms, and they're all related to those. These are the rules for logarithms. If we have inside the log two different terms that are multiplied, we can split it into two logs with the same base, and each one has one of those terms we add. When it is a division problem, we end up splitting it and subtracting. With a power taken to a power, this power goes on the outside of the log in front, so it's just a multiplication. We're going to see this rule a little bit later. It's called the change base rule. And any time that I have the exact same base with the log, I can basically cancel out the two logs and end up solving a problem that is just, so these two things are identical, and we're left solving x equals y. So if we just look at using the product rule, we have two things inside. We're going to split it into two separate terms. Both of those terms have to have the exact same log base, and one of them is a 4, and the other one is an x. So we could actually solve this guy, log log base 2 of 4. So 2 to what power gets me 4? That would be 2. So this ends up being 2 plus the log base 2 of x. In the quotient rule, what I see in here is division. So remember, I don't change what the log base is. So that's log base 6 of x. This is a subtraction problem. Log base 6 of 36. And this second one I can do, because 6 to what power gets me 36? Log base 6 of x minus 2. In the power rule, anytime we have a power, we are going to put it in front. So we end up with x times the log base 5 of 25. And since log base 5 of 25, 5 to what power gets me 25? That's going to be 2 times x. So we can have more than 2 terms in here, and we just work through them. Inside this log base 6, we have 36 times x, so that's going to change to a plus, divided by y, that's going to change to a minus. Each term is separated. Times is plus. The division is minus. So what number, 6 to what power gets us 36? This becomes 2. None of the others will change. Again, we think about everything that's inside, because this is ln. All of these terms are going to be replaced to ln. So I'm going to do ln of 5, ln of x to the 7th, and ln of y. When I see the power, remember the power comes in front. So this becomes 7 ln of x. And then, since these 2 terms on top are multiplied, that changes to addition. Division changes to subtraction. And ln of 5, I could do it, but it's an irrational number, so I'm going to leave it that way. To expand each of these, we're going to do log base 6, 3, and we are multiplying, so that means we're going to add. We have a power, so that power goes in front, and log base 6 of x. Here we have 3 separate terms. They're all going to be in ln form, ln to the 5th power. Now, since I have these 2 terms in the denominator, I really need to make sure that they are both subtracted. So I can think of this as ln of 12 and ln of x. They're both in the denominator, so I put parentheses around them. Then distribute the negative number, and I get both of these subtracted, so they're both in the denominators. Now we're going to go the opposite way. We're going to condense it back to 1 logarithm. In order to condense it back, the log has to be exactly the same base. Since I don't see anything, these are all base 10s, and that's a good starting point. So these are all going to go back together. The first thing that I like to do is move the thing that needs to become the power. So that one ends up being log base 10 of 2 to the third power. So then if I want to put these all into one term, that's going to be just regular logarithm. 9, that's going to go on top, plus becomes times 2 cubed, divided by 3 because that's subtraction. And in this case, I can do all of this, and I end up getting the log of 24. Let's do some more like those. I see subtraction, and subtraction is going to be division. So x is on the top, 9 is on the bottom, and it is common log, which is base 10. All of these terms are going to go inside except for this guy here. I'm going to switch to a power. So I'm going to have 4, because it's plus, it's times. I know, sounds a little weird, doesn't it? And divided by 12. Those are all inside natural log. And I can actually do those. Please make sure that you're not canceling the 3 out of here until you actually take this to the power. But I can see that 4 goes into 12 3 times. This is 3 cubed, which is 27. And 27 divided by 3 is 9. So this is the natural log of 9. If I have just one thing inside the log, I probably don't write it in parentheses. I think it's a really good habit to write the parentheses to make sure that you are taking the log of everything. So let's take a look at another one. First, I notice that I have a number in front, so I need to make that a power. So I'm going to put that inside as 3 squared. So I can go ahead and do that. I know 3 squared is 9. Then because this is addition, I know that it's going to end up being multiplied if they are both inside 1. So this is 24 times 9. That happens to be 216. And 216 is on our table that we had all of the powers. For 6, that is actually 6 cubed is 216. So the log base 6 of 216 is 3. We don't see that here, but it simplifies to 3. Now the next thing that we can do is the calculator does not have a button to give me the base of different logs. It only has log base 10 and natural log. So what we're going to do is split this up. So I see that this can be the log base 2 of 3 minus log base 2 of 7. And we have the values of each of those things. So this one ends up 1.585. And I'm going to subtract 2.807. And then I just do that, number crunch it. So we are using the rules to simplify to things that we actually have values of. So 21 in terms of 3 and 7 is 3 times 7. So this ends up being log base 2 of 3 times 7. And that means I'm going to split it. And multiplication is addition. I know it sounds a little weird. Which means I have 1.585 plus 2.807. problem. This, I could do this as I know it's 7 squared. So if that's going to equal 7 squared, it could be 2 times the log base 2 of 7. And that means it's 2 times 2.807. And that ends up equaling 5.614. So we can solve these by knowing just a few of the actual logs. In my next example, I have them based on log base 6 of 5 and log base 6 of 8. So in my first one, go away, I see log base 6 of 5 minus log base 6 of 8. And that ends up being 0.898 minus 1.161. Negative 263. 40 in terms of 5 and 8 is 5 times 8. So this one is going to end up being log base 6 of 5 plus. Now I do want you to write these out so I know what you're thinking. So this ends up being, and don't try to skip steps, and you just use the calculator. So that is 2059. Okay, so if we solve a couple things, we can. Continuing on, 8. If 5 doesn't come in this, but 8 does, this could be 8 squared. And that would be 2 times the log base 6 of 8, log base 2, log base 6 of 8. Oops, why am I doing that? I could also write them out as multiplication, and I would be doing 1.161 plus 1.161, so that's going to be 2.322. This doesn't have an 8 in it, it does have 5. I can think of this as 5 cubed, which means I'm going to do 3 times the log base 6 of 5. That gives me 0.898. 2.694. Okay, this is how we can use a calculator. So since I'm showing you this, please make sure on the other ones that you're showing me the steps. So the calculator has 2 logarithm buttons. It has common log and it has natural log. It doesn't have log base 2, or log base 5, or log base 6. So the way that I split that is I'm going to go to the log that I want, which in this case, we're just going to label it as b. It's usually going to be log base 10, and I'm going to do log base 10 of the inside divided by log base 10 of the base. I can equally do that in terms of natural log. These two things are both going to give me the exact same value. So what does that look like? Log of the inside as log base 10 is the common logarithm over log base 10 of 3. And then you grab the calculator please don't make the mistake of not closing the parentheses. So I grab a calculator, and I'm going to do this. When I hit the log, and then I say, okay, log base 10 of 8, you have to recognize that there's a little parentheses right here. You have to close it. Divided by a log base 10 of 3, close parentheses. So you need to have the parentheses closed or you will get the wrong answer. The correct answer is 1.89. If I did it incorrectly, without thinking, I do not get the correct answer. So this is 1.89. I can just as easily do that using common logarithms. So this is going to be ln making it ln of 24 over ln of 6. Hello, girls. And again, please make sure that you remember to close your parentheses. If you do not do that, you will be wrong. And I have to add something in here because I didn't catch my 2. Natural log 24 divided by a natural log of 6. And we have 1.77. Okay, so in a word problem, hey, sometimes they give you the equation. Look for that. So we have an equation, and that equation has an I, which is watts per meter, and that is going to be the amount of power that we have. And the recording artist wants to double that volume. And they want to see how the loudness will change. If you think about what that's doing, that means for the new power, they are going to do 10 times the log of 2 times whatever the initial amount is. And remembering that division is subtraction, we are going to do subtract the initial amount. So let's clean these up. These powers are both going to go on top of these. So we are going to have log of 2 to the power 10, I to the power 10 over IO to the power 10. And that is also going to happen over here. So when we actually clean this whole thing up, and we split these guys out, we're going to get log base 2 to the 10th power plus log of I to the 10th power minus log IO to the 10th power. Then because this is already subtraction, the numerator is subtracted and the denominator becomes added. And even if we plugged in the barely visible sound in here, they would end up canceling out. Log of the initial sound minus that sound, log of barely decibel plus that. So those all cancel out, and the only thing that I have is log 10 2 to the 10th power. And what I get for that is that it is about 3 times more powerful. Looking back at the top to see what loudness is measured in, it is measured in decibels. And so this final answer is 3 decibels. Your homework is on Google Classroom. If you have questions, make sure you check in with me. We will probably be doing a homework help again on Wednesday morning.